Alright, so here are some other rules for derivatives. We aren't going to derive these results. We're just going to make use of them. You can refer to a calculus book for explanation, but these do work. If I take e, the famous number e, raise it to the x power, if I want to differentiate that function with respect to x, turns out it is e to the x. The derivative of e to the x is always just e to the x. It doesn't change. Okay, it's a very unique little function that way. The derivative of the natural log of x, and in this class, and in a lot of math and stat classes, when we write log, we'd mean natural log. Okay, so just get used to seeing that. Log is actually natural log. So the derivative with respect to x of the natural log of x is 1 over x. We have something called the chain rule. If I have a function of a function, like f is a function of g of x, then the derivative of f of g of x with respect to x is, first I differentiate f with respect to g, okay, and then multiply that by the derivative of the function g with respect to x. And finally we have something called the multiplication rule. Okay, if I have the product of two functions, and I want to differentiate the product of those two functions with respect to x, it's the derivative of one times the other plus the derivative of the other times the one. Okay, so let's do some examples here. Let's differentiate this function e to all this stuff with respect to x. Now see, I look at this form and I see it's e raised to some stuff. It looks kind of like this, but the stuff is not x up here in the superscript. The stuff up there is actually a polynomial. I'm going to need the chain rule here because this is a function of this is e raised to some other function. So I can write it like this, right? Okay, so I'm gonna use the chain rule. Up top here, this will be my function g of x. Okay, so the chain rule says to take differentiate the function f, which is e to the x. Differentiate that stuff with respect to all of this. Okay. Okay. Oops, plus 100 there. It's a 100. Remember that derivative doesn't change, but then I multiply by the derivative then of this function g. So that's going to be, what's the derivative of this polynomial up here? It's actually 15x squared minus 1, right? And then we're done. Okay. How about this next example? Calculate the derivative of natural log of this polynomial with respect to x. So again, it has this form log x, but there's not just an x sitting there. There's actually a function, which is the form of a polynomial again, sitting in there where the x is. So I'm going to again apply the chain rule in this case, and I'm going to have let's see. So the derivative with respect to x of log 5x cubed minus x plus 100 is then, it's going to be 1 over all of that stuff, 5x cubed minus x plus 100. Okay, then the derivative, the chain rule says to multiply then by the derivative of the function itself that's inside here with respect to x. So that'll be 15x squared, right? Remember the exponent comes down, you multiply, and then you lower the power by 1, minus 1, right? Because this is really x to the first, so the 1 would come down, you get minus 1 x to the 0, minus 1 x to the 0, okay? And the constants just vanish, so that one's done. Okay, let's do another example. Calculate the derivative of log of 5x cubed minus x plus 100, x to the 5th minus 3x with respect to x. So this is even more complicated. So first of all, so let me just write down what we're doing here. Oops, the derivative of log of 5 x cubed minus x plus 100. All that raised to the x to the fifth minus 3x. And by the way, when we write it like this, we mean log of all of this stuff. Okay. Now, if I remember my rules for exponents and logs and stuff, I'll remember that I can actually bring this power down and multiply. Okay, so it's x to the fifth minus 3x times log of that stuff there, 5x cubed minus x plus 100. Okay, so now I've got the product of two functions here. Hey, you know what? I already know what the derivative of this stuff is. I'll remember that we've already differentiated this factor. It's up here. So using the product rule, I'm going to take the derivative of this times this stuff plus the derivative of this stuff times this stuff. Okay, so the derivative of this stuff is going to be, remember, the exponent comes down. You get 5x minus 3. Whoops, forgot the 4 up there. That's the derivative of that stuff, and then times this stuff stays the same, log of 5x cubed minus x plus 100, and then plus, now I take the derivative of this stuff times this stuff. Let me do it in reverse order, just because, okay, and then so derivative of this stuff is given up here to be, maybe I'll write it like this, 15x squared minus 1 over 5x cubed minus x plus 100. Okay? Very good. So sometimes you can mix and match these rules. You can use them several times over and over, and there you go.